Okay, so inequalities now. So in this question, in 2020, question 18, for which x is the following inequality satisfied? So we want this function to be greater than 0. Now that means that either the numerator is greater than 0 just means positive. So we either want the numerator to be positive and the denominator to be positive, or we want both of them to be negative, okay? So first of all, we need to think about when are these functions individually positive. So how do we do that? We should solve it and then plot it, okay? So if we solve it and plot it, so we can do the first one, 2x squared plus 3x minus 2 equals to 0. So this clearly gives us 2 times 2 is minus 4 to factorize. Remember, we times a and c to factorize. Minus 4 is made up of 4 and minus 1, which adds to minus 3. So 2x squared plus 4x minus x minus 2 equals 0. So we're picking from here the 4 and minus 1 as they add to 3. Okay, so that's why we split it to the 4 and minus 1 there. And then we factorize the first two to give 2x x plus 2. And then we minus, because we want to get x plus 2 again. I could factorize it as plus x minus 2, plus minus x minus 2, but we want to get to x plus 2 to combine the two. So it's better to take minus 1 out. Minus 1 times what gives minus x is going to be just x. Minus 1 times what gives minus 2, and that will give us a plus 2 that we wanted. Now, we have 2x minus 1 of these x plus 2s. So 2x minus 1 off those x plus 2s. And then we can solve each bit. So this will be 2x minus 1 equals to 0. X equals to the what plus the 1 to the other side divided by 2. And then this will be x plus 2 equals to 0. X equals to minus 2. Now we can plot it. We've got the x-intercepts, and the y-intercept is the minus 2 is c for the quadratic functions. So that will be for this one, it will be half minus 2, and it will cross the y-axis at minus 2 as well. So that will look something like that. Okay, I'll have another go at drawing that. Okay, I think that's okay. So that will be 2x squared plus 3x minus 2. I'll just put that as the numerator, okay? And then let's do the other one in green, 2x squared minus 3x minus 2. Exactly the same thing. Now, I know they look quite similar, but they're different functions, so we need to do it again. So 2 times minus 2 is minus 4, minus 4, 2, which two things times to minus 4 and add to minus 3? Will be minus 4 plus 1 this time. So it will be 2x squared minus 4x plus x minus 2 equals 0. Yet again, we will factorize the first two and the last two. First two, highest thing is 2x. 2x times what gives 2x squared will be x. 2x times what gives minus 4x will be minus 2 plus then simply x minus 2. This time, so it will be 2x plus 1 x minus 2 equals to 0. Set that first bit equal to 0. 2x plus 1 equals 0. X will equal to minus half, or x will equal to 2. Okay. Now let's try to plot that. So we have intersection of minus half and 2 and minus 2. So it's a reflection of the other one, isn't it? Okay, so that's fine. Don't worry if you didn't get the reflection part, because that's not crucial to the question. Just an observation, denominator. Okay, so that now is the denominator. And when is, remember, we can either have, in order for it to be satisfied, it's either positive divided by positive or negative divided by negative. Now let's look at when they are both positive. So they are both positive This one is positive for this region, isn't it? So this one is positive for less than -2 and greater than half. So both positive. The numerator needs to be x needs to be less than -2, or x needs to be greater than half. And then for the denominator, x needs to be, for it to be positive, we're going to want this region here. So that is going to be x less than -half or greater than 2. And we want both of these. We want both positive. So this is clearly an and. So the case is either less than -2 or less than -half. So clearly we're going to want x is less than -2. And we want greater than half or greater than 2. So clearly we're going to want greater than 2. So that's definitely when they're both positive. Sorry, that should really be an or. So that's what I was trying to change there. Because that is the case. It could be either of those and we're both positive. Or we want both negative. Okay. So both negative is this, the negative for this first one is this region. So -2 to a half or -half to 2. Okay. So the numerator, let's check that again, was -2 to half, -2 to half, and the denominator was -half to 2. Okay. So we want to we want both of them. So we need to at least be greater than -half. We could be greater than -2, but -half is a stricter condition. So that means we need to be greater than the -half. And we need to be less than 2, but more strictly, we need to be less than half. So it is between those regions, okay? Now, that's the second condition. So now what I would do, I would try both of them. So let's try something like -5. So you can try -5. So 2 times 25, 50, -15 is 35, -2 is 33. So that would be 33 on the numerator if we had -5, which is positive. And 25 times 2, 50 minus the 15 would be, or plus the 15 this time, would be 65, definitely positive as well. So positive, positive, so that works, okay? We could try 0, which was another one of our solutions. 0 would be -2, -2. So -2 divided by -2. If x was 0, we'd get -2 divided by -2, which is 1, so greater than 0. So I'm just trying solutions there. Just literally, once you've got your solutions, try it. I've written quite a lot of inequalities here. So if I were you in the PAT, I know I put 2 lines there to indicate that's my answer. But you can either write it again, or you could maybe draw a box around it just to show that that was your final answer. So those were our final answers. Okay, great. The course notes will be available in the course, so just find them and make sure to try these questions yourself to make sure that you can do them yourself. Okay.